All right, hello everyone, welcome back to another video. In this video, we're going to be taking a look at boiling point and which substances have the highest boiling point, which have the lowest, what contributes to this, and what is basically the chemistry behind having a high boiling point or having a low boiling point. Now, boiling point is all about something called intermolecular forces. Intermolecular forces. These are the forces that exist between molecules in a substance. So suppose if I have a glass of water, right? This water, these are individual molecules of water. They're just existing in the glass, and they have formed forces between them, right? They have forces between them. So these forces that exist between the molecules and hold them together in this liquid form, this is basically called intermolecular forces. And let's not get this confused with these forces. These are called intramolecular forces. And intramolecular forces are forces which exist within one specific molecule. All right. So let's not get confused between that. So in this video, boiling point basically breaks or overcomes intermolecular forces. It doesn't tamper with intramolecular forces. That is something different. So let's just make sure that we're clear with that. And there are three main type of intermolecular forces that you need to know for the IB. The first one, which is present in all molecules. So this is the very first one that you'll probably learn even in school, is something called London dispersion forces. Now let me erase this real quick. So, sorry, intermolecular forces. So the first one is called London dispersion forces. And these forces exist in every single molecule, any substance, any molecule, any atom, they exist everywhere. They're everywhere, London dispersion forces. And these are the most common type of force. And you must also know that they are also the weakest type of force, intermolecular force. The second type are called dipole-dipole interactions. You might also see them as permanent dipole-dipole interactions, but these are stronger than London dispersion forces. They're stronger than London dispersion forces. I'm going to call it LDF, but they only exist in polar molecules. They only exist in polar molecules. So unlike London dispersion forces, dipole-dipole interactions have some specificity. They can only exist in polar molecules. So non-polar substances cannot have dipole-dipole interactions. The third intermolecular force that I'm going to look at is something called hydrogen bonding. And I'm sure you must have heard of this by now, whether you're a biology student or a chemistry student. You would have heard of this somewhere, right? Hydrogen bonding. Hydrogen bonding is the strongest intermolecular force, IMF, right? It's the strongest intermolecular force, but it is very specific. Hydrogen bonding can only exist in substances where you have nitrogen, oxygen, or fluorine bonded to hydrogen. So only in substances where you have a substance or a molecule like this present, only there can you have hydrogen bonding. And you may notice what's common between these three. They're highly electronegative. Fluorine is the most electronegative atom or element in the periodic table. It has an electronegativity of 4.2. Oxygen is the second most electronegative atom, and nitrogen is also very electronegative. So hydrogen bonding only exists in substances where you have hydrogen, which is attached to a highly electronegative atom. And I'm going to show you how that works in a second. Right? I'm going to show you how all of it works. But you must also remember that despite hydrogen bonding being the strongest intermolecular force, all of it is actually much weaker than something like covalent bonding. And if you have been paying attention, covalent bonding is not an intermolecular force. It is an intramolecular intermolecular force. And we don't have to deal with this now, but I'm just making this very clear so that you don't get confused in the future between intermolecular and intramolecular forces. And when we boil something, we are overcoming or we are breaking intermolecular forces. We are not tampering with intramolecular forces. Now, hydrogen bonding is basically forms because such an electronegative atom like fluorine or oxygen or nitrogen, they're very greedy, right? They're electronegative. They like electrons. They like pairs of electrons. So they draw the electrons in this bond towards themselves. So this fluorine gets a slight negative charge because remember, electrons bring negative charges. So when they get greedy and they draw these electrons toward themselves, they get a slight negative charge. And this hydrogen, which is now deficient in electrons, gets a slight positive charge, right? And these positive charges are attracted to other negative charges in the same molecule. So I'm going to show you what I mean by that by taking a look at water. Now, water, obviously, in water, hydrogen bonding can exist because you have a highly electronegative atom bonded to hydrogen, right? So this oxygen atom has a slight negative charge. These hydrogen atoms have a slight positive charge. And when this approaches another water molecule, this has a slight positive charge, slight negative charge, slight positive charge. This negative charge and this positive charge on this hydrogen, they form a bond with each other because they're attracted to each other. I'm sure you would have seen this by now that, positive charges attract negative charges and vice versa. And this bond right over here is called a hydrogen bond. So that's how hydrogen bonds are formed. Now, dipole-dipole interactions are somewhat similar, but they are weaker than hydrogen bonding. London dispersion forces, as I mentioned, are the weakest, and these London dispersion forces are constantly breaking and reforming because they're so weak. And the general rule is that London dispersion forces tend to get stronger as the molecular mass or the atomic weight of whatever substance that you have, as it increases, the London dispersion forces also become stronger. That is the general rule. And why does that happen? Well, it's fairly obvious because as the atomic mass or the molecular weight increases, that means you have more electrons, right? And if you have a higher number of electrons, you have a stronger bond or you have a stronger force. And that's why London dispersion forces get stronger as molecular mass or atomic mass increases. Now, let's take a look at the question now that we have tackled the concept of intermolecular forces. The very first option that we can eliminate is C. Why? Because, well, you can see over here that this is an alkane, right? And it's just a hydrocarbon chain. It just consists of carbon and hydrogen. And this substance is non-polar. And as we mentioned, non-polar substances only have one type of intermolecular force, which is London dispersion forces. And London dispersion forces are very weak. So it is impossible for this to have the highest boiling point out of all of these substances. So that's out. What about, let's take a look at the next question. Let's take a look at this substance over here. CH3COCH3. Now we have an oxygen over here. And this substance, if you were to draw it out, it looks something like this. Wait, I hope you all take a photo of this because I'm going to erase it now so that I can make space to draw the molecules. Now, this substance, CH3COCH3, if you have reached organic chemistry, or if you've learned it, it's basically a ketone. It's a substance called a ketone, where you have carbon, which is double bonded to an oxygen, and another carbon. This is a ketone. And as you can probably tell, this is a polar substance. It's polar because this oxygen is highly electronegative, so it has a slight negative charge. And obviously this carbon has a slight positive charge. And remember what I told you about electronegative atoms earlier. They're very greedy. They like to draw the electrons toward themselves, and that gives them a partial negative charge. And as I also mentioned, between polar molecules, in addition to London dispersion forces, you have another type of force that can occur in the intermolecular forces, which is called dipole-dipole interactions. And if you are kind of confused about what I'm talking about, just rewind the video a few minutes back, and you'll see what I mean, what I explain. And between this molecule and another molecule of the same kind, so if I copy this and if I just paste it, oops, that's the wrong one. Anyways, if you were to take this molecule and another molecule of the same kind, they would have London dispersion forces and dipole-dipole forces occurring between them intermolecularly. Okay, and that would make it stronger, definitely stronger than the molecular forces in the non-polar substance, intermolecular forces in the non-polar substance, because like I told you, they only have London dispersion forces, whereas polar substances have London dispersion forces and dipole-dipole interactions. Now, what about this substance over here? What about this substance? CH3, CHOH, CH3. And as you can probably tell by looking at this OH over here, there is a possibility of hydrogen bonding occurring over here. Now, let me show you how that works. So let's take a look at this, right? I'm going to erase this. Remember, in this molecule that I showed you right over here, this molecule, the ketone, hydrogen bonding cannot occur because hydrogen is not attached to any highly electronegative atom. It's only oxygen which is double bonded to a carbon. So hydrogen bonding cannot occur over there. However, hydrogen bonding in this is an alcohol, hydrogen bonding can occur over here. And let me show you how that happens. So let's put this CH3, CH, actually, OH, CH3. All right. So this is how this alcohol looks like. This is propanol. And let's see, when this propanol molecule approaches another propanol molecule, so when this propanol molecule approaches another propanol molecule, much like this, there is in this group right over here, right? This is the hydroxyl group. There is a slight negative charge on the oxygen and there's a slight positive charge on the hydrogen. And I've explained why this occurs before. And this negative charge is attracted to this positive charge. And there you go, you have a hydrogen bond that is formed between these two molecules of propanol. And not only do hydrogen bonds form, there are also dipole-dipole forces and London dispersion forces, right, between molecules, because this whole molecule over here is polar. It is a polar molecule. So that means that dipole-dipole forces can exist and hydrogen bonding can also occur. And London dispersion forces exist anyways between molecules, as I have mentioned. London dispersion forces exist in all molecules. So this is pretty strong, right? They have hydrogen bonding, and hydrogen bonding is the strongest intermolecular force. But what about this substance over here? CH3CO2H. This is a carboxylic acid. And a carboxylic acid looks something like this. Carboxylic acids have the Cu group on them, and the Cu group is basically this. This is a Cu group. And these have the strongest intermolecular forces. And why is that? Well, this has hydrogen bonding. Why isn't this strong? This can also have hydrogen bonding. And not only one hydrogen bond, but two hydrogen bonds. Because as you can see over here, the hydrogen bond can only occur between the hydroxyl group of one molecule and the hydroxyl group of another molecule. But over here, hydrogen bond can occur in two instances, and I'm going to show you how that works. So let me just first erase this, and then I'm going to show you how that works. So imagine this carboxylic acid approaches another carboxylic acid, right? The exact same. All right. And as you know, this has a slight positive charge, this has a slight negative charge. And because oxygen, which is highly electronegative, is bonded to this oxygen is going to have a slight negative charge because of its electronegativity. And the exact same case over here. And this negative charge is going to attract this positive charge. And so you have one bond which forms over here. And this positive charge is going to form bond with this negative charge, this oxygen atom right over here. And there you go. Look at that. You have two hydrogen bonds being, or the possibility of two hydrogen bonds being formed between these molecules, right? And this is why they have such a high boiling point, because they're so strong, right? You not only have to overcome one hydrogen bond, but you have to overcome two hydrogen bonds, which makes them very hard to break. And thus they have a high boiling point. And I think from that, you must be fairly certain that this molecule, the carboxylic acid, this is ethanol, by the way, ethanol is going to have the highest boiling point. So we can eliminate D, and now it's between A and B. Like I said, even though this is a polar molecule, this has hydrogen bonding, and hydrogen bonding is really strong. It's the strongest intermolecular force. So this is going to be stronger than this, which means that A is wrong, and that means that B is our correct answer. Now, hopefully I've done a good job at explaining that. I know it is very confusing, and I know it can get a bit messy when you're doing this in the exam to think about what is polar, where does hydrogen bonding occur, where it doesn't occur. But hopefully I've given you a good foundation to quickly spot which are the polar molecules, which is non-polar, where can hydrogen bonding occur, where can hydrogen bonding not occur, how many hydrogen bonds can occur in a molecule, and then you are on a good path to tackle such questions. Thank you so much for watching this video. If you have any other questions regarding this concept or any other concept, feel free to reach out to me on my social media. I'll be more than happy to help you. See you in another video with another question. Have a good day.